My purpose here is to measure the efficiency of a remote control airplane or quadcopter propulsion system consisting of a brushless motor, an electronic speed controller, which is underneath here, and a battery. So the parts that are involved in this setup are the motor itself, the electronic speed controller, a load cell, and the associated HX711 amplifier, a Hall effect current sensor right here, the Arduino Uno, an SD card reader to save all the recorded information. Now, the one other component that I have here is this light dependent resistor that I'm using to record. So to measure the power in, I have the 3-cell LiPo wired through a voltage divider that are going into my Arduino Uno, and doing that so that I keep the voltage below 5 volts. And then I also have the current sensor. This is I believe it's a 20 amp Hall effect current sensor. So the voltage times the current gives me my power in. Now, to get my power out, I'm measuring the rotational speed by counting the number of shadows that the light dependent resistor sees, and also measuring the force that is applied to this load cell. And then by knowing the force and the radius, this distance, then I have the torque, and then the torque times the rotational speed gives me the power out. So I'm doing it this way because this gives me the entire efficiency of the propulsion system. The piece that I really don't have a way of modeling is the ESC. Maybe there's a way to measure the efficiency of an ESC. I've seen some work done to try to do that, but I haven't seen a good way to do it. Okay, I'm going to kick off the, make sure I got my SD card in here. Yes. I'm going to kick off the compile the set so that I can kill the setup anytime. Now it starts by measuring the PWM, the force, the voltage, the current, and the RPMs. And the way I'm doing this is to look at what the force in grams of force, and once that gets to a point where it stabilizes, then I begin to record the data and save it onto my SD card. This is kind of a kludged up setup. I mean, this is a plywood frame in order to make these measurements, but it seems to work okay. And then the piece underneath here, this is a Lazy Susan type of bearing, and it has pretty low resistance if you mount it vertically in this fashion. And by doing this, I'm able to record the data. So what's happened here is it was running and the force was increasing, and then it got to a point where it stabilized, and I started recording the values. So I'm recording 10 or 11 values here, and then I'll stop recording and it'll change the input as it just did there, and then it'll wait till it stabilizes again, and it'll start recording values, and it continues in this fashion. And by doing this, I can get a profile of what my propulsion efficiency is based upon the pulse width modulation input. Pick up here, it's recording right now. So at the end of this, it'll go up to 1275.
25.